Alright, I wanted to get example out some functions that are a little bit more interesting than the little polynomial stuff we did in class. So here's a function of two variables. We're going to look for local min, max, and saddle points within this area. Now they said between x between -1 and 7 because we got a periodic function here, so the list could actually go on forever if we extended it on out, I suppose. But we're just looking between -1 and 7 for x, so we're only going to let that go for a little while. But we're just looking for these points within the interior of this slice. So I got to find critical points in here. So I got to find my first partials. First partial derivatives. F sub x, the derivative of this thing with respect to just the x variable. First term is going to be 0. This is going to be 2y sine x. Derivative of cosine is negative sine, so that comes out positive there. And then f sub y, the derivative just with respect to y, be 2y minus 2 cosine x. So you start to have some interesting stuff in these partials. So solving for critical points is a little bit more thought-provoking here. We need both of those to equal 0. 2 times y times sine x has to equal 0, and 2y minus 2 cosine x has to equal 0. So you could attack this a few different ways, but what jumped out at me was that these are factors right here. This is multiplied. So I got a 0 factor property from this thing. Tells me either 2y is equal to 0 at this point, or sine x is equal to 0, which within our x values that we're looking at, that's going to be at 0 and pi and 2 pi. And that would be it within that region of the plane anyway. So we got those possibilities just from here. Now think those in conjunction with this here. If y is 0 and this is also 0, substitute that in here and we got -2 cosine x equals 0. So cosine is 0. So this is x is pi over 2, 3 pi over 2. Those are the values where cosine is 0 within that restriction. So we got ordered pairs. Pi over 2, 0. 3 pi over 2, 0. That's that y with those x's. And we'll probably get some more over here. If x is 0, then this thing here tells us that 2y minus 2 times 1 equals 0. So 2y equals 2, y equals 1. So I got 0, comma 1. If x is pi, then 2y minus 2 times -1 is 0. So 2y equals -2, y equals -1. So we got pi -1. And if 2 pi, if x is 2 pi, I got 2y minus 2 equals 0 again, so y is 1 again. So I got 2 pi, comma 1. All of those are different from the ones we got here, so we got quite a list. Critical points within the interior of this space that we got over here. We want to classify those as either local min, local max, or saddle points using this determinant thing that we have that we called capital D, which was product of those partials minus the mixed partial squared, sort of a determinant thing. So I need to get second partials. So here's my first partial with respect to x. If I take another derivative with respect to x on this, I'm just getting cosine 2y cosine x. If I take the derivative of this with respect to y, I'm just getting 2 sine x. If I take the derivative of the y one with respect to x, I'm getting 2 sine x again. I knew that. That's fyx, but that matches up like it should. And fyy would be the derivative of this with respect to y, which is just 2. So d ends up being this times that, 4y cosine x minus this one squared. It's going to be 4 sine squared x. I don't really care about what that is as a function. I just want to know what that is at the points that are critical points. This is only meaningful at the critical points. So I'm going to evaluate that along my list of potential max min saddle points that I've already identified. I'm going to evaluate what that is. So I actually could make a table now, better sort this out. The x and y coordinates that I'm aware of that are potential critical points are all here. I guess I'll put these in x order. Those are like all points that are on the graph of y equals cosine x. But anyway, I want to know what the determinant is there. I'd also, ultimately, I want to know the max and min values if I get them. So I'd actually like to evaluate the function at those points, but I'd also like to evaluate this d thing at those points to see how they classify whether this is positive or negative. Okay, so f of xy is y squared minus 2y cosine x. I'm just going to plug the points in there. If x is 0 and y is 1, I got 1 minus 2. Yeah, negative 1. If x is pi over 2, I got 0 there. And y is also 0, so that's when f is 0 there. If x is pi, I got cosine of pi is negative 1. 1 minus 2 is negative 1 again. If x is 3 pi over 2, that's a 0, and y is 0, so that's 0 again. And when x is 2 pi, that's 1 again. I got 1 minus 2 is negative 1 again. That gives you kind of a hint as far as minimum and maximum stuff, but I want to do this d here also to clarify what's going on and know if I got any saddle points in here. So I'm evaluating this at these points also. X is 0 and y is 1, I get 4 minus 0. If x is pi over 2, I got 0 here, I got 0 here, and this is negative 4. If x is pi, cosine of pi is negative 1. This is 4 times negative 1 times negative 1 is 4 minus 0, so that's positive 4 again. 3 pi over 2, cosine is 0 again, sine is negative 1, but it's being squared here anyway, so I got negative 4. I'm doing this kind of quickly, but if I got 2 pi, this is 0, and this is 1 times sine is positive 4 again. When d is positive, that means it could be a max or a min. When d is negative, that's definitely a saddle point. So these are already conclusive. These I need to know a little bit more about. These are max or min. And in order to tell that, the quick way to tell that is just look at concavity along just in the x direction. So go back to what fxx was, which is 2y cosine x. Think about that value. It doesn't matter when d was negative, but that's how I classify things if d was positive. So I need to evaluate that at these points. X is 0 and y is 1, I got 2. Positive 2. If x is pi and y is negative 1, that's also positive 2. And if x is 2 pi, that's 1, and this is positive 2 again. So fxx is positive at all of those. Positive means concave up. That means min. I got 3 local mins where the function hits negative 1, and I have 2 saddle points where the function's at 0. I'm going to do one with boundaries and with critical points and boundary values also in a separate video.